In everyday usage of the smartphone, we occasionally delete text, photo, and the movie which we have cared very much. And this may be due to the carelessness, or it may be due to intentional erase of evidence which may be harmful to oneself. So what we are doing is we apply our own knowledge of the open source and our own development of the C Sharp, and the Python to restore these deleted files in text, voice, and motion picture. We used the both commercially available TenorShare Ultidata and also the Dr.Phone's application, as well as for the new application that our clients want, we developed ourselves using C, C Sharp, and Python. Recently, you can come across with the many reports of such erased or deleted files in the smartphone, like Iyong case in Korea, and also in the United States, there are many terrorists or the many criminal activity which erased the files. And also in Hong Kong, there are many evidences of deleted messages, which is very crucial in the court. And also in Japan, that the messenger or the SNS played a crucial role in the gathering the digital forensic evidences. So what we supply to our clients is, if it is available readily using the commercially available application like a TenorShare Ultidata and the Dr.Phone, we use it. And if this commercially available application does not so, like the KakaoTalk in Korea, Line in Japan, and WeChat in China, we develop our own knowledge which is based on the scientific principle, and then we applied the C and the C Sharp and the Python to solve this problem for you. Fortunately, this restoring is very well developed in the digital forensics, and the representative one is the test disk and the photo rack, whose source code is on a GitHub. So when you look at the source file of this test disk and the photo rack, you find the many patterns which this program recover. And for example, in a JPEG, which is a photo, they look first at the header, that is the FFD8, and then in the middle there is photography, and the end of the image there is FFD9. So it is quite straightforward to write the C code to detect the header and the end of the image and then recover the photo. And similarly, the basic scientific principle why we can recover deleted files are obvious when you look at the header of the device. So first, if you look at the device as a header, the first that is FAT32, that file allocation table, 32-bit, which was used by the MS-DOS, and is also currently used widely. And then after this file header, they describe the list of the files. And then after that, they just delete this list of files without touching the actual files after this header. So the basic reason is that when you try to delete all this file actually, then their storage space is around to 4 giga to the 500 giga. It will take around 30 minutes to 5 hours to overwrite all these deleted files. So in practice, this is not feasible. So actually they just deleted the header, the list of files, without touching the remaining files. Process of recovering the deleted data is through the photo rack. We first put the folder to the deleted files, and then this photo rack first identify this FAT32 file format, and then it looks the partition, and then which partition is the FAT file location table or the NTFS next technology file system. And then we examine the whole partition devices, and then we set up the target directory where this recovered file are written. And then the process goes through all deleted files, and then usually for 2 to 4 gigabytes of deleted file, it will take around the 30 minutes to the 40 minutes. So the remaining, the movie shows that the 10 times accelerate the frame for this photo rack recognition. Let us examine the recovered photos and the movies. The recovered photo file has a very clear-cut header, which is a FFD8, and then the end of the image contains the FFD9, and between the start of the image and the end of the image, we have the actual photo content. The similar cases are observed for the MP4, the movie format. The header of MP4 contains the FTYP, and then the P3, and then string also M dot. So by identifying the beginning header of this MP4 file format, and then we scan through the data structure of the MP4 file format. So that's how we recover the motion picture. The case is a little different from the messenger. For the messenger, for the KakaoTalk in Korea, they use a SQLite 3 database, and when you look at the directory folder of the Android or the iPhone, you can find that there's a KakaoTalk database. And there is also the similar database with the shared memory, SHM, and then the write or the logging, WAL databases also. Now, when you look at this KakaoTalk database, there is a chat logs table, which is crucial and which contains the message information, which are vital for the digital forensics. And this message is encrypted in the advanced encryption standard. So when you look at it through the SQLite 3 database browser, then there is gibberish, the encrypted message. So in the next YouTube, we are going to discuss how to solve this AES, the advanced encryption standard, by decrypting it. And then we present the solution, and then we provided these services to our client. Our email address, and then also address of the KakaoTalk and the Telegram, and then also our telephone number are listed. We are located in Chongryangri, Dongdaemumku, Seoul, and then you can visit our shop, and then you can discuss personally with us. So we welcome your request for our services, and through this email or KakaoTalk, Telegram, or the telephone, or directly visiting our shop, and then we'll satisfy your needs using the commercially available application, and then added or augmented by our own further development of C and Python. Thank you.